So, what are the key differences between Bitcoin and Ethereum? They are aim. The most important difference between Bitcoin and Ethereum is the overall aim for which they have been created. While Bitcoin was created as an alternative to national currencies and thus aspires to be a medium of exchange and store of value, Ethereum was intended as a platform to facilitate immutable programmatic contracts and applications via its own currency. Mining. Bitcoin and Ethereum 1.0 mining is based on the so-called proof of work algorithm. But Ethereum 1.0 is being upgraded to Ethereum 2.0 that will use another algorithm called proof of stake. It is interesting to note that Ethereum has fairly faster block time, the amount of time necessary to validate a block. Bitcoin's average block time currently is a little bit more than 8 minutes, while Ethereum's block time is around 15 to 25 seconds. Hash. The cryptographic hash algorithms used by Ethereum is ETH-hash, whereas Bitcoin uses SHA-256. Transactions on the Ethereum network may contain executable code, while data affixed to Bitcoin network transactions are generally only for keeping notes. Let us now look at the limitations or disadvantages of Bitcoin. Degree of acceptance. Many people are still unaware of Bitcoin. Every day, more business organizations are accepting Bitcoins, but the list remains small and still needs to grow in order to benefit from network effects. Volatility. Bitcoin prices are very volatile and increases or decreases at a very high pace. Speculators wish to take advantage of it, but genuine investors think of it as too risky and therefore all the investors do not invest in Bitcoins. Ongoing development. Bitcoin software is with many incomplete features in the active development. New tools, features and services are being developed to make Bitcoin more secure, convenient and accessible to the masses. Some of these are still not ready for everyone. Most Bitcoin businesses are new and still offer no insurance. Possible government interference. Well, the government may not take your Bitcoins away, but can ban it in the country, which forces Bitcoin wallets and companies to shut down. The Bitcoins in these wallets are frozen and access to them becomes difficult. Deflationary. We discussed that how Bitcoin being non-inflationary can be an advantage to the economy. But one possible negative factor attached to Bitcoin because of being deflationary is that if it gets in the hands of a speculator, a huge recession will come in Bitcoins. Bitcoins are limited in numbers, and if the major chunk is held by speculators and investors, they will hold it for a longer period of time and won't release it in the market. When the supply of Bitcoin will be short and demand continues to increase, it will increase the price of Bitcoins and then the speculating investors may get benefited. Lack of recourse. If you lose your Bitcoin wallet, you have lost all of your Bitcoins in that wallet. You cannot regain it and they are simply lost forever until and unless you have backed up the wallet with a backup phrase code. The backup phrase code can be used to recover the lost Bitcoin wallet balances. In case of a credit card or a debit card stolen, we can call the merchant to cancel the card and request for a new one, but in case of Bitcoins, as it is decentralized and no one has control over it, we don't have any person or organization to call. Money laundering or black market. The complete anonymity of user base in Bitcoin lends itself to be used as a mean for money laundering and people operating in black markets who did not want to reveal their personal information and get payment secured. In money laundering, middlemen or intermediaries would collect money from one source and transfer it to another source through Bitcoins. Let us now look at the limitations or disadvantages of Ethereum. Scalability. The concerns held on the scalability of permissionless blockchain platforms are a significant hindrance to their wider adoption. The main reason for the Ethereum scalability problem is the network protocol that each node in the network has to process each transaction. Ethereum 1.0 implements a slightly modified version of the proof of work consensus mechanism. In Ethereum, miners have to race to find the nonce to meet the target difficulty. Every node needs to verify that the miner's work is valid and keep an accurate copy of the current network state. This greatly limits the transaction process capability and throughput of the Ethereum blockchain network. Let us look at another term, namely blockchain scalability trilemma. This scalability trilemma, as explained by Vitalik, is a concept in blockchain regarding its capability to address scalability, decentralization, and security without compromising any of them. The trilemma claims that it is almost impossible to achieve all three properties in a blockchain system. Decentralization. This is a core tenet upon which Bitcoin blockchain were created. Decentralization enables censorship resistance and permits anyone to participate in a decentralized ecosystem without a central authority or intermediary. Security. This refers to the integrity and immutability of the public ledger and the ability to resist 51% or distributed denial of services like network attacks. Scalability. This concerns the ability to handle a growing amount of transactions in the blockchain network. In order for Ethereum blockchain to be the world computer as the inventor envisioned, it needs to match the transaction throughput of many centralized systems like Amazon, Visa, or MasterCard. The following diagram is an illustration of the scalability trilemma in the blockchain. Challenges with smart contracts in Ethereum. Smart contracts probably are one of the most widely discussed applications to result from the rise of blockchain technology. They permit companies to create trustless and automated agreements. These smart contracts are considered fulfilled only when specific conditions built into the contract are met. Not only do they facilitate the development of applications directly on the chain, but they also work with tokens that provide considerable utility for various types of financial transactions. These factors have facilitated considerable speculation over its potential to affect numerous industries from law to logistics to finance. Smart contracts are designed to facilitate the performance of trackable and irreversible transactions without the need for third-party involvement. Therefore, as a result of this lack of oversight, it is essential that these smart contracts are written and properly tested. In addition, the smart contracts have to provide three essential properties. They need to be deterministic, isolated, and terminable. This we have covered already in the session on smart contracts. The first property is deterministic, meaning that they need to produce the same result each time they run. Isolation is the second condition for a smart contract. A smart contract can be uploaded by anyone, which introduces a risk since any single contract may, by design or by accident, contain viruses and bugs. If the contract is not isolated, this could impact the entire blockchain ecosystem. Therefore, contracts need to be isolated in a sandbox to save the entire ecosystem from any negative effects that one contract could introduce. The third condition, termination, is also essential in smart contracts since, by definition, a smart contract must be capable of completing within a specified time limit. Smart contracts are like any other computer programs or software and therefore need to be maintained. There are four types of maintenance that is needed with any software. They are corrective, adaptive, perfective, and preventive. Given that smart contract cannot be modified once deployed to ensure concept of immutability, which in theory does not allow to change the blockchain's past. The immutability is applied to all transactions in the blockchain, including transactions used to deploy smart contracts and the associated code. In other words, once the smart contracts code is deployed to the blockchain, it will live forever as is. No one can change it. If a bug is found or a new functionality needs to be added, we cannot replace the code of a deployed contract. If a smart contract is immutable, then how are you able to upgrade it to new versions? The answer lies in deploying a new smart contract to the blockchain. But this approach raises a couple of challenges that need to be addressed. The most basic and common ones are: all users that use the smart contract need to reference the address of the new contract's version. The first contract's version should be disabled and forcing every user to use the new version. Usually, you need to make sure the data or the state from the old version is migrated or somehow available to the new version. In the most simple scenario, this means you need to copy or migrate the state from the old version to the new contract's version. One thing that has come out very clearly from all the discussion around limitations is the scalability issues and how they are hampering the wider adoption of blockchain. We will cover this topic and possible solutions in another session.